This section is the most important part of the course, and sharing this information is the main reason this course was created. In this lesson, we will extract analytics performance information from the Pi system, convert it into a convenient format using Microsoft PowerShell, and then summarize the data in Microsoft Excel to gain understanding about how our analytics are performing. If you work through the entire course, at the end we will run through this activity again to see the results of changes made in other sections of the course. The first step to analyzing the performance of our analytics is to export the performance data from Pi System Explorer. To accomplish this, we'll launch Pi System Explorer. We'll go to the Management tab in the lower left. And then looking in the lower right under Pending Operations, we'll right-click and select View Analysis Service Statistics. This window gives you performance information about a number of your analytics, but it's not the easiest format to look at at a broad scale. So instead of just looking at the individual analytics themselves, we'll click Save and save the resulting text file to our C class folder, and then we'll analyze that file later in Microsoft Excel. Next, we'll use Microsoft PowerShell to convert the data from XML to a more easy to analyze format like CSV. So first we'll launch PowerShell. And if you haven't used PowerShell before, it's like an upgraded command prompt with some more functionality that we'll take advantage of. Once we're in Microsoft PowerShell, we'll use the change directory command to change to C class. Once there, our next step is to import the XML file that we exported in the previous step into Microsoft PowerShell. For all the content in this class, we've copied the PowerShell and Excel content that you'll need to use into a file called PowerShell and Excel content to copy.txt in the C class folder. So we'll open this file, Microsoft PowerShell. We'll press enter to execute the command. So now inside this XML document variable, we have the contents of our analysis service statistics.xml that we exported from Pi System Explorer earlier. Next, we need to store the relevant performance information into a different variable, basically the information that we're interested in, called eval summary. So we'll take the next line from our copy and paste file, and we'll copy that over, and then execute. Next, we're going to parse that data and export it into a CSV format so that we can analyze it in Microsoft Excel. So if we click back into our PowerShell and Excel content to copy.txt file, and we'll copy the third line there into Microsoft PowerShell. This line parses the data in the eval summary variable and exports it to a CSV file that we can then analyze in Microsoft Excel. Once that's complete, you should see a anperfstats.csv file created in your C class folder. Next, we'll take a look at this anperfstats.csv file inside Excel. So if you double click on that file, it'll launch Microsoft Excel. If the Microsoft Office activation wizard comes up, just press cancel. And then once you're inside this file, informational statistics about your analytics. So in the first column will be the display name, which is which analytic it is, specifically the element that the analytic lives on, and the name of the analytic itself. You'll see the average elapsed, which is the amount of time it takes on average for the analytic to complete, the maximum elapsed time, which is the max amount of time it took to complete during the statistics, the average lag, which is the lag between when the analytic should have executed and when it did execute, and the maximum of that lag as well as the duration of the data export and the number of times that the analytic executed during that period. Once we have this file open in Excel, we'll click Save and say No to convert it to an XML format. We'll save it in our C class folder, and we'll change it to an Excel workbook. We can leave it the same name, amperfstats.xlsx, and click Save. Now we want to enhance this data with a few more columns that will help us in our analysis. The first thing we want to add is a template column indicating what analysis template was used to create this analysis. So we're going to insert a new column to the right of the display name column. And we're going to call it template. And the way we're going to find the analysis template is going to be using Excel parsing to find the data inside the brackets in the first column. So to accomplish that, we've put that information into our PowerShell and Excel content to copy.txt folder. So we'll copy the template column text and then paste that into the first row of our template column. And you can see that it pulls out revenue from cell A2. Now we're going to fill that down by double-clicking on the square in the lower right. And now you can see that all of our templates are visible for our various analyses. Next, we're going to create another column that is our average triggering interval. So to the right of execution count, we're going to create a column called average trigger. And we're going to get the average trigger time by dividing the data duration by the number of times that the analytic executed. So we've done this once again in our copy text file. So it should be G2 divided by H2. We'll copy that and paste into our column and then fill down. You can see here that most of our analytics are executing approximately every 10 seconds, but it varies from analytic to analytic. Next thing we want to calculate is something called weighting factor. This will be a combination of both how often an analytic executes and how long it takes to execute when it does. So to do that, we'll click into column J, and we'll call this weighting factor. Going to be C2 divided by I2. So we'll copy this text from our text file, paste it into the column, and fill down. So that's dividing the average elapsed time by the average trigger to determine a weighting factor for our calculations. The next step is to build a pivot table. We'll start by creating a new tab by clicking the plus button at the bottom of the Excel window. Once we've created our new tab, we'll right-click and rename and call this pivot table. On our new sheet, on the Insert ribbon, we'll select Pivot Table. And here where it says Select a Table or Range, we'll click over to our PerfStats column and select all the data. Once we've done that, click OK. And you should see all of our fields from our initial analysis show up in the pivot table fields column. The next step is to grab the template from the pivot table fields and drag it to the rows area in the lower right. This will show all of our analytic templates in the first column down the left side of the screen. Next, we're going to add some values. So we're going to drag average elapsed down to values. And we're going to change this to an average by clicking the drop-down, clicking Value Field Settings, and selecting Average. Next, we're going to drag max elapsed down to the values area. And we'll change this to a max, so that we can see the maximum of our max elapsed. Next, we'll do the same thing with average lag and max lag. So we'll drag average lag down, select the drop down, change it to an average. Then we'll drag max lag down and change it to a max. Next, we'll drag average trigger down to the values area, and we'll change it to average of average trigger. And lastly, we'll drag down our weighting factor, and we'll change this to average of weighting factor as well. So your pivot table, once you've dragged the fields down, should look something like this. You'll have your analytics along the left side, then your average of average elapsed, your max of max elapsed, average of average lag, and max of max lag, as well as average of average trigger and average of weighting factor. Next, we're going to enhance our pivot table with a few of the Excel functionality to show which analytics are causing problems. The first step for this is to sort the pivot table by the sum of weighting factor. We're going to highlight the row labels column and select the drop-down, and then select More Sort Options. And we'll select Descending Z to A by average of weighting factor, and then click OK. Now your pivot table should be sorted by the weighting factor column, which is the most significant analysis of our analytics. After that, we're going to add some conditional formatting to highlight the analytics load caused by these various analytics by selecting the average of weighting factor column, excluding the header. And then on the home ribbon, selecting conditional formatting, data bars, and the data bars of your choice. This will highlight which analytics are the most expensive in our system. As you can see in my example here, high wind speed calculations is by far the most expensive of our analytics, closely followed by our loss power 30-day average. The goal of the pivot table we created in this activity is to be able to see which analytics are the source of the overall performance problems with asset analytics. In other words, we then know where to focus our efforts on improving performance. In particular, the weighting factor column is useful in determining which analytics to look at. This is because the weighting factor column that we created is a combination of both how long the analytic takes to execute combined with how often it executes. This is necessary because sometimes there are analytics that take a long time to execute, but don't execute very frequently, and therefore aren't necessarily worth it looking at to improve performance. One key factor to keep in mind is that the performance information in PySystem Explorer only shows the 5 worst performing instances of each analytic template. This is normally sufficient for our purposes, but in the scenario where you have thousands of instances of a particular analytic template, the pivot table we have built here might not be sufficient for your purposes. One way to deal with this scenario is to add an additional column indicating how many instances of each analytic template there are, and factor that into the weighting factor by multiplying it in the calculation. This will weigh the analytics with more instances more heavily. Another way to deal with this scenario is to contact OSIsoft technical support. Technical support has a special tool that will extract performance data for all analytic instances. The output of this tool can be used to create a similar pivot table, but with more detail about how many instances of each analytic there are.